Hello, how you doing, everybody? It's MrDoTheMath here. Today we are going to learn how to simplify radicals. All right. So, in simplifying radicals, this is what we're looking at. We're looking at a number with the square root bar and a number there, right? The number underneath the radical is called a radicand. Say it with me, radicand.
Radicand.
Right, radicand. And that's the number that we break down, right? And so when we're breaking down or we're trying to simplify this radical, what we're doing is what we did in our do now. It's basically made a factor tree, right? And when we're making our factor tree, we pull out the pairs. The pairs come out, and whoever's alone stays inside the radical. So here we go. So if we look at 50, so the other thing that we want to think about when we are simplifying radicals is we want to divide this number. That's what we're doing basically. We want to divide this number by prime numbers, right? So the number that we pull down first is the prime number, right? Since this is an even number, the first prime number that we'll be able to use is 2. So we'll divide 50 by 2. When we divide 50 by 2, we get what?
25.
We get 25. So basically what happens is you divide this number into this number and it'll kick back this number. Alright? And then when you break down 25, you can, it's not even, so you can't use 2. And it's not a multiple of 3, so you can't use 3. So the next prime number you use is what?
5.
5. So 5 divided by 25 is what?
5.
5. Now, here comes the simplifying of the radical part. Alright? What you're going to do is you're going to identify the pairs. There's a pair of 5s there. The pairs go on the outside. They go on the outside, and the 2 stays inside because he's not a pair, right? So what happens is you got a pair of 5, so the 5 is outside the radical, and the 2, which is alone, is left on the inside. And so when you simplify the square root of 50, you end up with 5 root 2. Okay? Let's look at another example. Let's look at 45. 45. All right. 45. It's not an even number, so we can look at 3. Can we divide this by 3? No? Yeah. So we use 3, and 15. All right. Then we can break down 15. 15 can be simplified to be what? 3 and 5. These are all prime numbers. Do we have any pairs here? 3. There's a pair of 3. So they go on the outside. So it's 3 goes on the outside and 5 is alone. And so there we have it. We have 3 root 5 is the solution here. Okay? Let's look at a more challenging one. You say 120? Alright, square root of 120. Square root of 120. Alright? 2 and who? 2 and 60. 2 and 30. 2 times 15. 3 times 5. Alright, let's circle the pairs. We got a pair here, and then there's these numbers left. 1, 2. Alright, so I'm glad we did this. So this is what happens. The 2 comes on the outside. Now inside we're left with a 2, a 3, and a 5. So what happens is you multiply these numbers together. So it'll be 2 times 3, which is what?
6.
6 times 5 is?
30.
30. So the solution is 2 root 30. Alright? Does everybody see that?
Yes, sir.
Alright. Now, there's something special about radicals. Within radicals, you're going to have radicals that you're going to have to simplify, and they'll stay in radical form. And then you have numbers called perfect squares, which will simplify to be just a whole number alone. Alright? And so, let's look at a perfect square. Alright? Let's look at a perfect square. What about the square root of 200 and, let's do 225. Right? 225 is a multiple of 5. Right? So if you divide that by 5. 5 divided by 225, you're going to get what? 2 is a 4.
You get 45.
It's 145. Go that way. Alright? And then you can break down 45 to be what?
You get
5.
9.
5 and 9.
I thought you said Yeah.
5 9?
It'd be 3 and 15?
Yeah, it can be 15, right?
3 and 15? Yeah, it can be 3 and 15.
Oh,
Doesn't
We can do 5 and 9. No, you get the same thing. Let's look at it. So, let's finish this one. 9 is what? Gonna be what?
3.
3 and 3, right? Now 45. Let's do it again. You say 3 and 15,
Yeah.
and that's gonna be what?
5 and 5.
Right? So now, let's identify our circle, like our pairs, right? So, let's circle our pairs. I didn't write this down. Circle your pairs. Circle your pairs. You got a pair of 5s, you got a pair of 3s. Nothing left, right? So 5 goes on the outside, and 3 goes on the outside. There's nothing left, so that's what you're left with. 5 times 3, which is 15. 15 is the square root of 225. It's a perfect square. Yes, ma'am.
So what if you would have used it that way?
What if we did it this way? All right, let's move it over here. Let's see. We changed this to be, you said 3 and 15?
Yeah.
3 and 15, you'll have 3 and 5. Circle your pairs again. It's a pair of 3s, and there's a pair of 5s. So you get the same thing. Okay? All right. Now, let's look at the situation if we have a variable there. So, the same thing applies for a variable. Okay? The same thing applies for a variable. So, for instance, we have the square root of 20x to the second power. Here's what I want you to grasp here. With variables, well, let's look at it this way. The square root is the same as a number being raised to the 1/2 power. Okay? Being raised to the 1/2 power. Which means, and so you can look at this and it can help you simplify variables better. So for instance, if you got this x to the second power, that's like x to the second power. It's x to the second power. And if you rewrite x to the square root to be to the 1/2 power, it's going to be basically 2 times 1/2. Right? So 1/2 times 2 is, what's half of 2? 1. It'd be x. Right? So if this was x to the 4th power, you would get, it would basically be x to the 1/2 times 4. What's half of 4? 2. Okay? And I'm finna show you how else it looks like. So just table that. Alright? So the first thing you want to do is you want to factorize the number, right? Factor the number. Alright, so you got 20. 20 is gonna be what? 2 or 10, right? And then 10 is gonna be what? 2. Let's do 5, 2 and 5, right? So with the number, do we have any pairs?
2.
2. So you pull 2 out. 2 goes on the outside. 5 stays inside. Alright? Now, let's look at the x. X to the second power means we have how many x's?
2.
2. X and x. Do we have a pair?
Yes.
Yeah, it's a pair. So it just comes out.
Oh, x going. Oh, I get it.
Yeah, so he goes out as well. So the answer is 2x root 5.
So what if you have 3x? Like x to the 3rd power?
Okay, I'm glad you said that. Let's look at one so then we can talk about it. Alright, let's look at this next one. The square root of 10y to the 5th power. So, let me put our steps down. The first thing you want to do is you want to factor the number. Second thing you want to do is you want to circle in pairs. And then you want to rewrite it, right? Rewrite it, right? Now, when you got variables, you repeat these steps, right? So 10 is going to be what?
2 and 5.
2 and 5. Any pairs there?
No.
They stay underneath. So you got the square root of 10. 2 times 5. Now, y to the 5th means you have 1, 2, 3, 4, and 5. You got 5 y's. Okay? How many pairs you got?
2.
Won't. And you got 1 left, right?
So then I'll go by 10.
So he goes, the one by itself goes here, and the 2 pairs go here. So you got y and y, because you said you got two pairs of y's, right?
You want to put y squared?
You would. I'm just doing an extra step. So you got y times y, which is y squared, times the square root of 10y. Everybody see that? How we feel?
Good.
Alright. Let's make this one a little bit more snazzy. Let's look at the number 5 one. Let's look at the number 5 one. It's more difficult, right? Because a lot of times teachers, we teach like the easy one and leave y'all with the hard one. Alright, so look. We got the square root of 112. X to the 2nd. Y to the 15th. Z to the 8th.
Oh, man.
Okay? Ready? Number 1. Factor the number. Alright? So that's going to be 2 times what?
56. 2 and 28.
2 and who?
28.
28. 2 and
14.
2 and
7.
2 and 7. How many pairs you got?
We have 2.
4.
You got 4 pairs of 2.
2.
Right. So yeah, you got 2 and 2. 2 times 2 and that's 4, right? 2 times 2, right? 4. Okay? Here we go.
7.
And the 7 stays underneath. Now the first thing I'm gonna do is let's focus on this x. So you got x and x. Right? So x comes out here. Let's give some more space. So you got x out there. Y to the 15. Alright, y to the 15, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Alright? Alright, this is just the harder way. 2, 3, 4, 5, 6, 7. 1 left over, right? So, we got 7 pairs. So y to the 7. Alright? Y. We got 1 left over. And then you got z to the 8. 2, 4, 6, 8. 1, 2, 3, 4 pairs. I'm glad you said that, Kahaja. So your answer is going to be 4x, y to the 7th, z to the 4th, times square root of 7y. That's it. Now, do you notice anything about these exponents compared to those exponents? Kaja said it earlier. They're in order? Yeah, they're in alphabetical order, yes. Anything else? Kaja, what did you say about, what's another way we can simplify these? I mentioned it earlier. You can divide by 2, because remember, the square root is times 1/2. So if you take half of 2, 2 divided by 2 gives you what? 1, to the first power. 15 divided by 2, you're going to get 7 and 1/2. That's why you get 7 here and another one. 8 divided by 2? 4. Y'all see that?
No, I didn't see it.
Yes, sir.
So if it doesn't have
It stays inside. Yes. Yeah. So, you said you don't see it.
No, I see it now. I'm saying I
You see
see
it
it, but yeah.
All right. So, here's the analogy that one of my students made. She was just like, let's use this next example. Let's do just numbers, just variables. Y to the 6th, Z to the 7th, right? She was just like, if it's a pair of them, they can go out, right? They can go out and party. But if they single, they got to stay in the house. The house being a rattle.
Still, yeah.
Right? So here's the thing. Let's look at this again, just like I said before. You got x to the 5th, right? If you divide this by 2, you get what?
Oh.
3, 4.
You get 2, and then you have a 1.
No.
You have 2 and a 1/2 left, right?
Yeah.
So that means you can pull 2 out, right?
I'm so slow.
And you got an x still. You got 1 left. What about 6 divided by 2?
3.
Y to the 3rd. And then you got z divided by 2.
1.
I mean 7 divided by 12, sorry.
You'll get 3 and then you got 1 left.
You got 3 and 1 left over. So 1 left over. Alright, let's look at it again. X, 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 X. 1, 2, right? 1 left over. That's how you got the 2 here, 1 left over. Equal with that. The same thing with the Z's. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. 1 left over. So you have 3 pairs, 1 left over. Okay? And then with the Y's, you just had 6 of them. 6 Y's. 1, 2, 3. 3 pairs, they go outside. Do you understand that?
Yes.
Yeah. Okay. And that's pretty much it. That's simplifying radicals. Alright? Don't forget to like and subscribe. MrDoTheMath out.